Hey everybody, welcome back. Today 10.5. We're going to be talking about sine and cosine ratios. Yesterday we discussed tangent ratios. Today sine and cosine. So let's go! Alright, so we're going to be finding the sine and cosine of acute angles today. Alright, so you'll be given a triangle and you're going to be finding the acute angle in that right triangle. Alright? So as you remember, sine, cosine, and tangents are all ratios of different legs in the hypotenuse or different legs over legs. If you remember SOHCAHTOA, which is going to be on my next slide right here, SOHCAHTOA, sine meaning opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. And those all correlate to their specific angles that you're trying to find. Okay, so if I have a right triangle here, I would be looking at, let's say, the sine of A. The sine of A, again, opposite over hypotenuse, so my opposite angle would be y, and I'd have the sine of A is equal to y over x. The cosine of A would be the adjacent, which is the next door neighbor of angle A, not the hypotenuse, but on the other side, so the adjacent. So that would be z over x. And finally, tangent is opposite over adjacent, which is y over z. Now, all of that changes if I start changing my angles. Like if I had the sine of B, cosine of B, or tangent of B, things would change around. Okay. However, your hypotenuse doesn't change. In this triangle, your hypotenuse would always be x. What would change are your adjacent and your opposite legs. So be careful with which one you are finding. Make sure you are finding, if it asks sine, make sure you're finding sine. If you're finding cosine, make sure you're looking at cosine. So remember, SOHCAHTOA. Today we're going to be talking about sine and cosine, or so and ka. Okay, so remember those, so, ka, and toa. All right, here we go. All right, so right now we're going to be using our calculators. Remember, we are going to be using our calculators a lot, so make sure you are bringing your calculators home when you have these videos and to school, because you do need your calculators both for notes and for your homework. Okay, so the very first thing I want you to do is you are going to be finding the difference or the different sine and cosine measures. All right, so I want you to pause right now, write this stuff down, and then we'll go through the sine and cosine buttons. All right, so it says, again, we're just using a calculator and we're going to be approximating the value to 4 decimal points. Now, for the sine of 43, make sure that you hit that SIN button on your calculator. On most calculators, I believe it's going to be 2 spaces above your 7. So if you look at your 7, go up to, you see SIN. You're going to hit SIN, sine 43, and you're going to get something around 0.6819986. Okay, we are going to be approximating for the value of 4 decimal points. Okay, so approximate signs, here we go, so it's approximately point, and we're going to round to those 4 decimal points, so you're going to get 6820. Do you need that 0? Yes. Okay, because it says 4 decimal points, so don't put 0.682 because that's not 100% correct. That's not giving me 4 decimal points. It's 0.6820. All right. Now the sine of 72, same idea. Hit that sine and hit 72, and you will get 0.951056516. Okay, so when we approximate, point our decimal point, it's going to be 9511. And the sine of 90, this is a special angle measure, okay? And when you get this, we do have the approximate to 4 decimal points, but this one's going to be a whole number. There's no decimal points behind it, and your answer is 1. Okay, go with cosine. It's going to be above 2 spaces above your 8 on your calculator. So hit your cosine and then hit your 43, your cosine, then your 72, cosine and 90, and let's check them out. All right, so cosine of 43, you'll get 0.7314. Cosine of 72 is about 0.3090. And the cosine of 90, again, a special angle, which is 0. Okay, it's going to be cosine of 90 and sine of 90 are two special angles, and they're going to be 0 and 1. Okay, all right, so now let's get into the different ratios. Okay, so right now I want you to write the directions, and I want you to draw that triangle. And what we are doing is we are going to be finding the sine of b and the cosine of b as ratios, as a fraction, and then we're going to find those decimals. Okay, so I want you to pause now, draw the triangle, and if you think you have an idea of how to find sine, remember, so opposite over hypotenuse. So opposite over hypotenuse, ka for cosine, ka is adjacent over hypotenuse. Okay, so try to find those and then get your fraction measures or angle. Your cosine. Oh my goodness, Mr. Sheen, what's going on? All right, here we go. So right now we are finding the sine of b. Okay, so we know the sine of b is going to be equal to, and again, for so is opposite over hypotenuse, the sine of b, so we're looking at the opposite of my b angle, which is 24. So I have 24, and my hypotenuse is always going to be the same, of 25. Okay, so we know the sine of b is always going to be 24 over 25 in this triangle. Okay, so when I set that equal, I just take 24 and I divide by 25 to the nearest hundredth. I'm going to get 0.96. 0.96. Okay, I took opposite over hypotenuse. Okay, now what we do is we're going to do the exact same thing for cosine. Okay, so I'm going to put cosine down here. Cosine, again, ka on the bottom for cosine is adjacent over hypotenuse. So I'm looking at B, and my adjacent angle or adjacent side is going to be 7. So the cosine of B is equal to 7. That's my adjacent side over hypotenuse. My hypotenuse still stays the same, and that's going to be 25. So they're going to stay the same because my hypotenuse is always AB here. Even though I may switch my angles, I may switch my trigonometric ratio between sine and cosine, but my hypotenuse will always stay the same. I take 7 divided by 25, and I get 0.28. I do not take the cosine of 7 over 25. Okay, take 7 divided by 25, and you will get your answer. All right. All right, here we go. We're going to move on. Now we're going to really get into some numbers. All right, so now we are going to be finding x and rounding to the nearest hundredth. Okay, so given the information that you are, I want you to come up with which ratio you think you should use, and then plug that into a formula and solve for x. Okay, so we're going to be talking about sine or cosine. So if I want to find x, which trigonometric ratio am I going to use? And then I want you to try to solve that. Okay, give it a shot. All right, so the very first thing I'm going to do is I need to write a formula, or sorry, not a formula. I will need to write an equation to figure out what x is. Okay, so notice according to this angle right here, I have this 63-degree angle, so I'm going to use that. Okay, I'm going to use that to find my x. If you look straight across, my opposite side is x. So my opposite side of 63 is x, and I also know my what? What is 12.9? That's my hypotenuse. Okay, so I know I want to figure out my opposite side. and I know my hypotenuse, so opposite and hypotenuse, I'm going to use sine. Okay, so I'm going to take the sine of 63, because that's my angle, is equal to x over 12.9. So the sine of 63 is equal to x over 12.9. How do I solve for x? I'm going to multiply by 12.9 on both sides, and I get 12.9 times sine of 63 is equal to x. So what do I do now? I use my calculator. My calculator does this work. All right, so I take 12.9. I'm going to multiply by the sine of 63, and x is going to equal 11.49. Okay, about 11.49, because I'm rounding to the nearest hundredth here. Now, am I done? No. Notice right here with my 12.9, I have centimeters. So what do you think I have to put as a label? Centimeters. Yeehaw! Okay, so what we are doing, make sure that you plug it in correctly into the right formula. You know cosine and you know sine now. Okay, you could have also used, if you wanted to, you could have used r, but you would have had to calculate what r would be as far as an angle. And if you would have done that, you would have found r was 27 degrees. And we know that because this is a right triangle, so we automatically, if we know two angles, we know that third angle, which is 27. You would have taken the cosine of 27 is equal to x over 12.9, and you would have came up with the same answer. All right? All right. Now, moving on. All right, here we go. Now what you are doing is you are finding both the x and the y in this problem. So what I want you to do is I want you to come up with your x and your y using the ratios of cosine and sine, or just one or the other. Okay, you could use all sine here. You could use all cosine here. Whatever you feel comfortable with, I want you to try it. Give it a shot. All right. So here I'm just going to be trying to find x right off the bat. Okay, so notice according to this 42-degree angle, x is my opposite side, and I also know my hypotenuse. So what trigonometric ratio am I going to use if I know an angle, the opposite, and the hypotenuse? Opposite, hypotenuse, that's so, which means I'm going to use sine. So I'm going to take the sine of 42, and I'm going to set that equal to x over 9.5. Okay, now I'm going to do my one operation, multiply by 9.5 on both sides. And I'm going to find that I'm going to take 9.5 times the sine of 42, and that's going to give me x. So when you take 9.5 times the sine of 42, x is going to be 6.4. Notice it asked me to round to the nearest tenth on this one. Watch your directions. Make sure that you're rounding correctly. Do not think, well, if I need to round to the 10th all the time, I need to round to the 100th all the time, I need to find 4 decimal points all the time. No, look at the directions to make sure that you write it correctly. Let's go back to the problem. So x is equal to 6.4. Am I done? No, I'm not done. I can't forget my label. Inches. 6.4 inches. All right? All right. Now we're going to be finding y. Okay, so on this one, if I erase this little triangle, here we go. We're going to be finding y here. In relationship to the 42-degree angle, y is my adjacent side. I still know my hypotenuse of 9.5. If I know my adjacent and my hypotenuse, I'm going to be finding ka, which is cosine. So cosine of 42 is equal to y over 9.5. How do you solve for y? I'm going to be multiplying by 9.5. And this tells me 9.5 times the cosine of 42 is equal to y. So y is equal to what? Say it out loud. Say it out loud. Say it out loud. 7.1. Don't forget your inches. 7.1 inches. Excellent. All right. So this is sine and cosine. You're going to be finding the SO opposite over hypotenuse and the CA adjacent over hypotenuse. That's all I have for you today. You will be getting your assignment tomorrow, and we'll be talking about this later. If you have any questions, make sure you ask. Make sure you ask any questions that you have. All right? Awesome. Thank you very much. Have a wonderful day.